Now, you are welcome to the part 3 of this course. And here, we are continuing to solve questions using the Kirchhoff current law and the Kirchhoff voltage law. So let's say we have this question that we want to find the current within all the circuits. So now, as we have learned already, let's say I want to call here I1. This time, let me say I want to call here I2. Then what do you think is going to be here? You can see that I1 is entering, I2 is entering, is equal to what you want to look for. So you put I1 plus I2 here. Now let's say I want to call here, say I3 like this. What do you think is going to be here? You realize that I3 is entering and is equal to I2, which is leaving, plus X, the one you are looking for. So here is going to be I3 minus I2. So by now you should be able to assign current direction and in the process apply the Kirchhoff current law to minimize the amount of loops you need to take. Let me just redraw this question where I have 7 here, this here, that's this, and this, and this, and I have my 10 volt here. I have my 2 ohm here. So the here too is 2 ohm, 3 ohm, and 5 ohm here, 2 ohm here, and 7 volts. Now, another person too could have gone by this way, saying here is I1. This one says here is I2. And by now you should be able to use your eye to say here is I1 minus I2. Then say you want to call here, say I3. Then you should be able to now see that here is becoming I2 minus I3. And you can use this assignment and use this assignment, and you are all come to the same answer. So I want you to use this first assignment, try it by yourself, and see the answers that you're going to get. And you're going to maybe try with this, and then after compare your answers and realize that you get the same answers. The only thing is that sometimes I may get my current to be a positive one and you get negative, or you get a negative one and I get positive, and it's all boiling down to the same thing. So let me first start with my first loop 1. So let me take this one in the clockwise direction. You can see that here will become 7 is equal to 2I1 following the arrow, plus here will become 3 and following the arrow direction, I1 minus I2. This is equation 1. And in writing this means you understand the concept. Make sure when you are breaking down the loop, you do the right thing. So here will be 7 is equal to 2I1 plus 3I1 minus 3I2. And you end up with loop 1 as 5I1 minus 3I2 as equation 1. Now, I want us to look at equation 2, which is this loop. And I want us to go in the clockwise direction. Let's write that on the next page. So here will be what? 5I2. Then here will be 2I2 minus I3. And here will be what? Minus 3 because I'm against the arrow direction. I1 minus I2. So we are going to have what? So we are going to have 0, 5I2 plus 2I2 minus I3. Then we had minus 3I1 minus I2. This is equation 2. And this means you have understood the Kirchhoff law. When breaking down, make sure you don't make a mistake. Here is 0, 5I2, 2I2, 2I3, 3I1 plus 3I2. Right? So here becomes 0 is equal to now 5I2. Let me write the I1 first. So minus 3I1. 5 plus 2 is 7. Plus 3 is 10. So plus 10I2. And then minus 2I3. Equation 2 is done. Now I'll come back to the question and I want to take this loop. And this time I want to go anti-clockwise direction. So you can see it's 10. And here will be minus 2I3. And here will be positive 2I2 minus I3. So we realize that we got 10 is equal to minus 2I3 plus 2I2 minus I3. This is your third loop. In taking these three loops means you are done with Kirchhoff laws. The rest is your simplification process and solving the simultaneous equation. This one will give you 10 minus 2i3 plus 2i2 minus 2i3. And you're going to get 10 is equal to 2i2 minus 4i3. So you're just going to pick your calculator, take equation 3, equation 2, and equation 1 we just did, and punch, and you are going to get your I1 to be 4 on 3, I2 to be minus 1 on 9, and I3 to be minus 23 on 9. So if you solve the other way, either one of them will be positive or negative, or the other way, right? So try that yourself and realize we are all going to get the magnitude to be the same. One will just be negative and one will be positive, to show that you can assign your current direction anyhow when you are solving circuits with Kirchhoff. Now, as I said, Kirchhoff is so important because it helps us know the current in all the resistors at a go. So here, if I want to know the current in these two, I can see that the current is I1. So it means that my answer is 4/3. If I want to know the current passing through, so here, right, I use this circuit. So the current passing through this 5, I got I2 to be minus 1 on 9. So I can easily get the current here. Now, if I want to know the current that is passing through this 3 ohm, is going to be I1 minus I2. So I pick my I1 answer, which is 4 on 3 minus 1 on 9. I'll get the current. So easily I've used Kirchhoff and I'll be able to know the current within all the circuits. Now let's look at another question like this, where I have introduced a current source. Now one thing is that most of the time when there is a current source within the circuit, students get confused, because one thing I want you to always know is that I want you to note this, that you can never take a loop with a current source. Never take a loop with a current source. Why am I saying that? Now this question, before I solve, first of all, we have to assign our current direction. Let's call here I1. Now here, I'm not going to call here I2, because you see, I know the current I1, and this current source is also a current 2, I know. So I can use this I1 and 2 to know the current that is here, so that I will not call more current. So I can see that I1 is entering, plus 2 is also entering, and it's equal to what I'm looking for. So I'll call here I1 plus 2. Now, let's look at the situation where I say you can never take a loop with a current source. You can never take a loop with a current source. Now, let's try to take this loop. Now, here is 20 is equal to, here will become 2I1. Then what do you think will be here? Somebody will say plus minus 2, minus 2. Now notice that this is voltage and it's equal to voltage minus a current. This is a current. So you can't say voltage is equal to voltage plus minus or plus a current. So that is why you cannot take a loop with the current source unless you are aware of the voltage across the current source. If you are aware of the voltage across the current source, you can take that loop. But most of the time, you will not be aware of the voltage across the current source. So make sure that you mostly don't take a loop with the current source, because they violate the Kirchhoff voltage law concept, because a voltage should be equal to a voltage plus another voltage, right? Because the current source, any amount of voltage across it can maintain this constant current source, current, right? Can be 2 volts maintaining that current, can be 3 volts maintaining that current. So we don't really know the voltage across the current source, so never take a loop with it. What means that this question, I cannot take this loop. I can also not take this loop, because when I take the loop, I'll have the current source within the loop. So the only option I have is this big loop, which I can take to solve the question. So let's take that big loop. I'm starting 20 will be equal to, here is going to be 2I1. Then here plus 4 into bracket I1 plus 2. And this will be 20 equals to 2I1 plus 4I1 plus 8. And I'll get 12 is equal to 6I1. And my I1 is going to be 2 amp. Simple. So the current source, I've even made things easier. Just that you should know that you cannot take a loop with the current source. You can never take a loop with the current source, and I want you to note that. So let's say this question, I want you to find the current in all the circuits. Your answer, I1 was 2, so the current in this 2 is 2. If you want to know the current in this 4, it's going to be I1 plus I2, which is 2 plus 2, because my I1 was 2, and that is 4. Maybe this question I say, find the voltage across this 4 ohm resistor, and you are going to go by the same process. And when you get to know that the current here is 4 amp, if I want to know the voltage across this, I'll just do 4, which is the current, times the resistance, which is 4, and going to be 16 volts. Simply, you solve the circuit using the Kirchhoff laws. Now let's look at another question like this. Now in this question, it looks scary, and don't be scared with any question when it comes to Kirchhoff laws now, because you know how to apply your KCL and your KVL. And you know one important thing, that you're not going to take a loop with a current source. So this question, let me say I want to call here I1. Now you see here this 10 volts, there's a current coming from here, but I'm not interested in assigning a current because there's no resistor there. I'm assigning the current direction in the resistors within the circuit, right? So I'll not call there I1, I'll just complicate things, right? So because there's no passing through any resistance. So I call here I1, you can see I1 is coming here. Now, I will not be calling this place I2. Why? Because I know 4 and I know I1. So I can easily know the current that is coming here. And I can see I1 is entering plus 4 is also entering. So here is going to be I1 plus 4. Now here, I'm not going to call here I2. Why? Because I know the current here and I know the current here. And here I can see 2 is entering plus I1 plus 4 is also entering, equal to what I'm looking for. And I'm going to get I1 plus 6. So I'm going to call here I1 plus 6. Now, from what we have just learned, we cannot take this loop. Why? Because of this current source. We cannot take this loop. We cannot take this loop because of the current source, right? So the only loop you can take, let me use this black here, is starting from this voltage source, and I'll go through here and go through this way and go this way. This is the only way I can take without passing through any current. So the loop looks scary, but don't be scared about it, because that is the only loop you can take to solve the question. Just make sure you start at one point and don't pass through any current source and come back. And from here, in writing the equation for the Kirchhoff voltage law, I'll start with 10. So 10 is equal to, then here is going to be 2I1. Then here, I'm going to get plus, I'm following the arrow direction, I1 plus 4. Then plus here is going to be 4 into brackets, I1 plus 6. Good. Now this is going to be 10 is equal to 2I1 plus 3I1 plus 12 and plus 4I1 plus 24. And this is going to be now become 10 is equal to, this will lead me to having 2I1 plus 3I1, that is 5, plus 4I1, so I will get 9I1, and 12 plus this will give me 36. So I can see that this will become minus 26 equal to 9I1, and my I1 is equal to minus 26 over 9. And this, have you seen how simply we've just solved with just some few lines, just because we assign our current direction very well. We did not take any loop that has a current source in it. And we have solved this with the Kirchhoff laws simply. And this brings us to the end of Kirchhoff laws. And no matter any circuit that you get, don't be scared. Just assign your current direction anyhow. Follow the process to make sure you assign Kirchhoff, use the Kirchhoff current law to know the current in the corresponding branches. After that, use the Kirchhoff laws to take voltage law to take your loops, and make sure you don't take a loop with a current source, and you are done with Kirchhoff. Now, any question that has to do with Kirchhoff, you should be able to solve. Thank you very much, and you can put your questions in the comment section regarding Kirchhoff law. So make sure you watch the part 1, part 2, and part 3 of this video, and you'll be able to solve every question on Kirchhoff laws. Thank you.